Good day, everyone. This is our last presentation about normalization and Netflix viewing activity. Let's start with Netflix overview. Netflix is a global streaming platform with millions of users. It collects watch history, genres, and ratings to give personalized recommendation. Moving on to the business activity, Netflix tracks subscription, watch history, and ratings, then generate recommendation. With millions of users, it needs efficient data storage. Now, for the data management challenge, if all viewing info is in one flat table, it causes repetition, mismatched data, and slow searches. The solution is normalization, which organizes data into structured tables for faster and cleaner access.
Our top 5 business rules. First, the multiple streams. A user can watch multiple shows or episodes. Second, belonging. Each episode belongs to a specific show and season. Third, genre crossover. Each shows may fall under multiple genres. Fourth, captured moments. Each viewing activity includes timestamps and user rating. Fifth, no rewinds. Avoid repeating genres, shows, and episode information.
Let's go to the ERD of our viewing activity table. But first, what is an entity relationship diagram? An ERD is a visual model that shows how data entities in a database are related. It helps keep data structured, consistent, and free from redundancy. This is what an ERD looks like. In our Netflix viewing activity ERD, the viewing activity table is the core. It records every streaming event, like who watched, what was watched, on which device, when it happened, how long, and even the user's rating. Around this central table are 5 supporting entities. These are the tables that provide additional details to the core table. They store specific information that the main table connects together. The user table stores the account and subscription details. The device table tracks the device used like phones, laptops, or televisions. The title table contains all Netflix content while the episode table lists individual episodes for series titles. Title genre table manages categories like action or comedy. Since a title can belong to multiple genres, the title genre bridge table connects titles and genres to handle these many-to-many relationships. In summary, our ERD has 6 main tables, including the core. Together, they show how users' devices, titles, and episodes and genres all connect through viewing activity. This design avoids redundancy, mirrors real-world streaming behavior, and provides a reliable foundation for analysis and personalization.
Presenting to you is the entities and the attributes of our Netflix viewing activity. But first, let us define what is entity and attribute. An entity is any object or concept in the system that we want to store data about. This slide shows the entities in our system. In our case, the entities include user, title, genre, Netflix viewing activity, and so forth. Each of these represents something important that our database needs to track. An attribute is the detail or property of an entity. For example, this slide highlights the attributes of the given entity. The user entity has attributes user ID, username, and subscription type. The genre entity might have genre ID and genre name. The title entity has title ID, title name, and type.
Now let's move on to the relationships and cardinalities in our database. This basically explains how the different tables in Netflix are connected and how they interact with each other. The first relationship is between the user and the viewing activity. A user represents an account holder, and every time they watch something, a new record is added in the viewing activity table. This allows Netflix to monitor what was watched, when it was watched, and for how long. Here, the connection is one-to-many. One user can create many viewing activities, but each viewing activity always belongs to one user. Next, we have the device and the viewing activity. Devices are the tools used to stream, such as smartphone, laptop, smart TV. and a single device can be linked to multiple viewing activities over time. Since people usually watch repeatedly on the same device, the relationship here is also one to many. One device can generate many viewing activities, but each viewing activity is tied to exactly one device. Next is the title and viewing activity. A title refers to a movie or a TV series. A single title can generate thousands of viewing activity because many different users may watch it. In this case, the relationship again is one to many. One title can be connected to many viewing activities, but each viewing activity always records just one.
Let's proceed with titles and episodes. Not all titles are the same. Some are series which naturally break down into one or more episodes. Others are movies and thus don't have episodes at all. So when we look at the relationship, a single title can have 0 episodes if it's a movie or many episodes if it's a series. But from the other side, every episode must belong to exactly one title. Think of it this way. Stranger Tracks as a series needs episodes to exist, but a movie like The Birdhouse stands alone without any. This ensures consistency because no episode can float without being tied to a title. Moving on to episodes and viewing activities. An episode can exist in a database even if nobody has watched it yet. This means the episode does not depend on viewing activities to exist. But once viewers start watching, that same episode can generate many viewing activity records, one for each user and each watch session. Looking at the relationship from the other side, a viewing activity may or may not point to an episode. This is because some viewing activities are tied to movies, and movies don't have episodes. In those cases, the episode ID in the viewing activity table remains empty. So the cardinalities here are one episode can have 0, 1, or many viewing activities. One viewing activity can be linked to at most one episode, but it may also have none at all. This design works because every episode exists independently in the episode table, which means it doesn't rely on viewing activity to exist. Meanwhile, in the viewing activity table, the episode ID field is nullable. That means a viewing activity record can either reference an episode for a series or remain empty for movies, reflecting that not all viewing activities involve episodes. Now, let's talk about titles and genres. Genres act as classifications, like action, comedy, drama, and so on. A single title can belong to multiple genres. For example, the title Superman could belong to both action and adventure. At the same time, one genre like action can cover dozens or even hundreds of different titles. This creates a many-to-many relationship. To manage that complexity, we introduce a bridge table called Title Genre Table. In this table, we use the title ID and genre ID as foreign keys, linking each title to its genres and each genre to its titles. This approach connects data without duplication, keeping the database flexible and scalable.
Now, let's move on to the 3NF tables. Third normal form or 3NF is a way of organizing data so that each table only stores one type of information, and everything is connected through IDs. It helps remove unnecessary repetition and keeps the database clean and efficient. Now, this slide shows the transformed Netflix viewing activity data into 3NF. Instead of one messy table, the data is now split into separate tables, namely users, titles, genres, title genre, devices, episodes, and viewing activity. Each table has a specific role and links to others through unique IDs. This was achieved by spotting indirect relationships and moving them into separate tables with their own IDs. And this is the final viewing activity table, applying the previous 3NF tables. It tracks who watched, what, when, for how long, and whether they completed it, along with the ratings and episode details. Now, before 3NF, all data was crammed into one table, messy, repetitive, and hard to manage. After transforming it into 3NF, data is now split into clean connected tables. Each table now only stores one type of info and links through IDs. This removes redundancy, prevents error, and makes analysis easier. TrendF turned cluttered viewing logos into a structured system that's scalable, accurate, and ready.
Now let's proceed in discussing how the 3NF tables have satisfied the business rules of the Netflix viewing activity. For the first business rule, where a user can watch multiple shows or episodes, the tables involved here are the title table and the viewing activity table. The user table stores user information, while the viewing activity table records every viewing action. The user ID is the primary key in the user table and serves as a foreign key in the viewing activity table. Since each activity is logged as a new record, a single user can be associated with multiple activities. This creates a one-to-many relationship between user and viewing activity, fulfilling the rule that a user can watch multiple shows or episodes. For the second business rule, where each episode belongs to a specific show and season, the tables involved here are the title and episode tables. The episode table captures detailed episode information. It includes episode ID as the primary key and title ID as a foreign key, linking the episode back to the title table. Along with season and episode attributes, each record uniquely identifies one episode, ensuring it is correctly associated with a specific show and season. Next is the third business rule, where each show may fall under multiple genres. The title, genre, and title genre tables are involved here. The title table defines show information, while the genre table lists the available genres. To manage the many-to-many relationship between titles and genres, the title genre table is used as a bridge table. This table contains only foreign keys, which are the title ID and genre ID, that reference their respective tables. As a result, a single title can be linked to multiple genres, and a genre can be applied to multiple titles. For the fourth business rule, where each viewing activity includes timestamp and user rating, the viewing activity table alone is involved here. The viewing activity table contains the details of every viewing action. It records the date and time, the attributes watch date and watch time, the duration or the duration watched attribute, and the rating, provided by the user. Together, these attributes ensure that each viewing activity includes both a timestamp and a user rating, satisfying the rule. Lastly, for the fifth business rule, where repeating genre, show, and episode information must be avoided. The title, genre, and episode tables are the ones involved here. Normalization ensures that show, genre, and episode details are stored only once in their respective tables. Each table uses its own primary key, which are the title ID, genre ID, and episode ID, to uniquely identify records. Other tables reference these keys instead of storing duplicate details. This prevents redundancy and avoids anomalies when updating or maintaining the data. In summary, the Netflix viewing activity database design captures the core business scenario through well-defined rules, a clear ERD, and a fully normalized structure. By eliminating redundancy, ensuring data integrity, and organizing relationships between users, shows, episodes, and genres, the final design provides a reliable foundation for analyzing viewing patterns and enhancing the Netflix experience.